Hi, welcome to my video on the combination of transformations on the square root equation. State transformations on y equals root x for each. Let's do some examples. The equation is y equals the root of x minus 2 plus 4. So the transformation, notice the x is an x minus 2, so like the parabola, so that has a plus 2, so it moves. Plus 2 is 2 to the right, and the plus 4 on the end. So when x is 2, when x is 2, we get the square root of 0 is 0, so y is 4, so it's 4 up, plus 4 is 4 up. B, we have the inside the brackets a negative x, so a negative x indicates it's a reflection. It's reflected in the y-axis. Reflected in the y-axis because of the negative x, and it moves 3 down, minus 3. And if you think of it, this square root of x, the graph, starts at x 2, y is 4. And this one starts at 0, negative 3. C, what's the transformation on negative 4 times root x? Because it's negative, then it's reflected, and the y is negative this time. So if the y is negative, it's reflected in the x-axis. The y is negative, it's reflected in the x-axis. And the 4 is a vertical stretch because it's 4 times the vertical stretch of 4. D. Now to do this one, we have to make sure that we factor the 2 out. The 2 is the GCF, so 2 into 2x is x. 2 into negative 2 is negative 4. So in this factored form, now, because it's in terms of the x, like right here, it's 4 times, so it's a vertical stretch of 4. But with the x, you got to be careful. It's a horizontal stretch of 1/2. It's the reciprocal of 2. And it's x minus 1, so that means it's moved 1 right, because it's the opposite. X minus 1, it takes, when x is 1, we get a 0 underneath the root, so therefore 1 to the right is the horizontal translation. E, let's look at the x's. We have a negative x, so with a negative x, it's reflected in the y-axis because of the negative x. And we have the equation, which is the negative. I just write it right here. We take the negative out, so negative x divided by negative is just x. Negative 4 divided by negative is plus 4. So we have it reflected in the x, but the opposite of a plus 4 is 4. And my pen just ran out, or part of it, so I'll pick up another one. It's 4 left, because it's the opposite of x plus 4. And the y is negative, so it's reflected. The y is negative, reflected in the x-axis, driving it, making it go down. And the vertical stretch is 1/3. And it moves, 1 added to the y is up 1, translated up 1. So that's a bit of practice or examples. So now I have some for you to practice. State the transformations on y equals root x for each, so you can pause the video and work these out. Here we go. Let's see, let's deal with the x. X plus 3, that's a minus 3. So minus 3 is 3, it's translated 3 left. Because of the negative on the outside of the square root is affecting the y, so it's reflected in the x-axis. And it's plus 6 is with the y, so it's 6 up. and y equals root of 4x minus 2. So let's look at the x first. So we have 4 times x. So again, with the x, be careful. It's a horizontal stretch of reciprocal, which is 1/4. And the negative 2 is added, subtracted from the y, so it's down 2 or 2 down. Number 3, y equals 3 times the root of negative 2x plus 10, so y equals 3. So inside the bracket, I have to make sure it's in the factored form. So negative 2x divided by negative 2 is x, plus 10 divided by negative 2 is negative 5. Now let's look at inside here. In terms of the x, it's negative, so it's, because the x is negative, it's reflected in the y-axis, making it go, instead of going to the right, it's going to the left. And it has a vertical stretch of, again, you got to be careful with the x is reciprocal. And opposite of negative 5 is a plus 5, so it's 5 right. And because it's 3 times this square root, then it has a vertical stretch of 3. And number 4, y equals negative 1/2 root of x minus 1, subtract 3. Let's look at the x. X minus 1, so it's a plus 1, so it's 1 right. So everything is done with the x. Let's look at the outside now in terms of the y. Because it's negative, it's reflected. We have a negative times here, so that because that's negative, it's reflected in the x-axis, making it go downward instead of up. And it got a vertical stretch of 1/2. Remember, there's a 1/2 times, so you don't change it. You only change it when there's inside here with the x, or as a reciprocal. And negative 3 is 3 down. So let's see if we have some more to do. Okay. State the mapping rule for each on y equals root x. What is the mapping rule? So the mapping rule is x comma y, and notice the x is x plus 2, so that means it's the opposite of an x 2, take away 2. And the y stays the same, so it's a y minus 6. So the x, you do the opposite, the y stays the same. And the mapping rule here is there's no change in the x. Notice x, root x, no change in the x. So the no change in the x. So the y is a negative on the y and a plus 1. And y equals the root of negative. Let's see, have to make sure it's factored. So we're taking out the negative. We got an x plus 4. We're dividing these by negative. We're taking it out. Negative x divided by negative is plus x. Negative 4 divided by negative is plus 4. So the mapping rule is x comma y. And there's nothing in terms of the y, so the y is not changed. So the x is negative. And there's no vertical stretch is 1, so we don't bother to put a 1 in. And it's the opposite of a plus 4 is a minus 4. Number 4, we have the inside of the bracket is what effect on the x is a 1/2 x, so that's a 1/2, opposite of a 1/2, or reciprocal of a 1/2, sorry, is a 2 times x. And the y stays as is, so it's 3 times, so it's a 3y minus 2. It's only with the x that you do reciprocal and opposite. It's only with the x do you do reciprocal and opposite. Number 5, again, before we start this one, we have to factor the inside. So take the 3 out. 3x divided by 3 is x, 6 divided by 3 is 2. So, the mapping rule, let's see, let's deal with the x first. So I have an x, so it's 3, so that's a 1/3 x. Opposite of a plus 2 is a minus 2. And with the y, we don't change anything. Negative 1/4 y plus 4. So it's only with the x inside of here. Reciprocal and opposite. Whereas with the y, we just go 1/4 times y plus 4. And number 6, we have x comma y, and x is x minus 2, so it's the opposite of x plus 2, and y is not changed. Notice x plus 2. So when we put a 2 in, we get a 0. So that means it's adding 2 on, so that's why it's x plus 2, the opposite. And number 7, the mapping rule, x comma y, and we have the x is out. This is already factored perfect, so I have a negative. The reciprocal of 6 is 1/6 x. A minus 1 is a plus 1, so it's reciprocal of 6, which is 1/6 negative, and opposite of negative 1 plus 1. And the y is just times 4y. And we have another one to do. State the equation, work in reverse. So notice here I worked the mapping rule from the equation. Now I have the mapping rule. I have to write the equations, just switching it around. State the equation for each mapping rule on y equals root x. So the mapping rule is x minus 4. So that means it's x minus 4. It's the opposite, x plus 4. And the y don't change, so you add 6. Number 2, the equation. We have x is negative, so that's the root of negative x. And the y is a negative. No number here, only 1, so we don't worry about it. And negative 1. And we have this one, and we have the equation y equals. Now, we have a 7, so let's see, 7x, so it's the reciprocal of 1/7 bracket, and we have an x, that's a plus 2, so that's a minus 2. Notice, reciprocal of 7, 1/7, opposite of plus 2 is a minus 2, but it has to be in the factored form. And the y is 3 times y, so it's 3 times the bracket minus 1. We could also change that if you want. We could go 3 root 1/7 times x is 1/7 x minus 2/7 minus 1, or leave it like that. I'll say or that. And number 4, we have the equation y, and the x is a minus x, so the x got a minus on the x, and that's a minus 1, so that's a plus 1. There's a minus, don't forget they got to be in brackets. And the y is negative, and there's a 1, so there's a 1 with a plus 2. And that equation, if you wish, could be like this, negative x minus 1 plus 2. Notice when you go from the mapping rule to the equation again, this negative goes outside the bracket. This has to be in brackets, like this one right here. So that's changing it from the equation to the mapping rule to the equation, and describing the transformation. And if you like my video, click the like button, subscribe button, and notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.